And then for part B, let's take a look here. We want to get the ratio of speeds right before each hits the ground. So let's be clear. If you just look at this, the first question becomes, well, how am I going to calculate the speed? And this is a test on energy, so you will be using the conservation of energy. So that means you have this ball here. Its height is greater than 0. Its speed is 0. And then when it hits the ground, its height will equal 0 and its speed will be greater than 0. So when we actually set up our equation, so let's just work on getting the speed for B. We know that E gravitational is going to become E kinetic, and that means mgh will become 1/2 mv squared. And now we'll put in our number. So we have 1 kilogram, g is 10, the height is 20, and that becomes 1/2 times 1 times v squared. So just to be clear, when we simplify all this out, v ends up being 20 meters per second for B, for the second ball, for ball B. And then for A, we'll do a similar calculation. It's going to be mgh equals 1/2 mv squared. But now we're going to use the height at A, which is going to be 1 times 10. And then A is going to be 10 instead of 20. And then we're going to have 1/2 times 1 times v squared. And here that's going to be 200 equals v squared. And this is going to be the square root of 200 right here. And so when we simplify VB over VA as our ratio, that's going to be 20 over the square root of 200. And I think that works out to be like 14 point. Let's just double check. So 20 divided by the square root of 200 ends up being 1.4. 1.41, which actually works out to be like the square root of 2 when you actually check that out. So that's what we mean by a ratio. So you're expected to use conservation of energy to figure this out. Again, this question is constructed to be a little bit new, but it relies on things that I've tested you on repeatedly and that you've covered in other classes. Hopefully this one will be a little bit easier. So now we have twice the mass, and we'll say sphere B is 2 kilograms, and we'll say that sphere A is 1 kilogram. So let's determine the ratio of gravitational energy. So EA is going to be MAGH, which is going to be 1 times 10 times 20, and EB is going to be MBGH, which is going to be 2 times 10 times 20. And that's going to be 200 versus 400. So EB over EA, that ratio, is going to end up being 400 divided by 200, which is 2. Now, I'm going to do part C first, just to be clear. Since there is no air resistance, this means that the acceleration of B equals the acceleration of A, because the acceleration is just plain old g, which is 10 meters per second squared, because gravity is what's making it accelerate. So let's get the ratio of the speeds just before each hits the ground. So I know that EG at B equals 1/2 mb v of B squared. I'm using conservation of energy. And EG of A equals 1/2 MA times VA squared. By the way, this stuff here, I've skipped a couple steps on this, so you're going to need to kind of go back and look at previous questions to figure out how I've come up with this. So I'm working a little faster here. So I have 400 equals 1/2 times 2 times VB squared. And that's going to give me VB equal to 20 meters per second. And then for EG of A, I'm going to have 200 equals 1/2 times 1 times VA squared. That's also going to give me VA equals 20. So the ratio of speeds, VB over VA, is actually 1. They land at the same speed. Which makes sense because you knew that before, that if you drop them from the same height, they'll have the same final speed. So that wraps up that set of questions, and we'll take a look at the roller coaster question in the next video.